Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 1 class. It is 5.5, Direct Variation. This is going to be a new concept for you, but it's basically just using a formula, plugging numbers in. It's not that big of a deal. Hopefully, hopefully by the end of this video, you'll have a really good grasp on it, okay? Direct variation is an equation of the form y equals kx, where k is a non-zero constant and it expresses the direct variation. What direct variation means is there's two variables that directly impact one another. So as one goes up, the other would go up type of a situation. As one goes down, the other one would go down. So just an easy idea for this would be the more amount of snow that drops in a day, the greater the chances that you will not have school the next day. Somewhere along those lines, okay? K is called the constant of variation. You really need to remember that K is the constant of variation. And we say that Y varies directly as X. You're probably asking yourself, why do we learn direct variation? Well, there are all sorts of reasons. We use direct variation to determine how much money is needed for gas, how much a person can make at an hourly rate, how much a person will weigh on Mars. There are lots of fun and interesting applications for this. Okay, so what does K represent? It is a non-zero constant. It is known as the constant of variation. Okay? Find an equation of variation where y varies directly as x and the following are true. So it tells us that y equals 25. So remember that if it is y varies directly is the key word there, the equation we're going to use is y equals kx. So it tells us that y equals 25 and x equals 5. So what I'm going to do is I'm going to take 25, plug it in for y. I'm going to take my k value still there, and I'm going to put 5 in for x. To solve for k, I would divide by 5 on both sides, so k would equal 5. Now the equation that tells me that y varies directly as x is still this equation here. I'm just going to take my k value and plug it in for k. So this would be y equals 5x. And now we could use that same equation to solve other problems that are similar to that problem there. Okay? So on to b, again, I'm just going to put 1.6 in for y. I'm going to put 0.4 in for x. Divide by 0.4 on both sides. And k would equal positive 4. So y would equal 4x. And we could solve more problems that are very similar. Usually in a story problem application, that's where we would need to find our equation of variation there, direct variation. Okay? So we need to solve assuming that y varies directly as x. What you're going to notice here is we have the same, our normal type of problem in the front. But then it tells us that we need to find y when the x value has changed. That's what I was talking about a minute ago. We're going to use the equation after we solve for our k value to figure out what our new y value is going to be. So I'm going to go ahead and put 15 in for y. I'm going to put 3 in for x and keep my k value. You divide by 3 on both sides, so k would equal 5. Now I can write my equation of direct variation, which would be y equals 5x. Using this new equation, I can put 35 in for x. So y would equal 5 times 35, which would equal 175. So y equals 175. Okay? I'm going to do the same thing for b. So 30 equals k times 6. Divide by 6, divide by 6. Again, my k would be 5. So y would equal 5x. It tells us that our y value now is 10, so I'd put the 10 in for y. So 10 equals 5x. Want to solve for x. Divide both sides by 5, so x would equal 2. So my answer would just be 2. All right, so that is how we use the equation of direct variation. Here are some story problems that would give you a better understanding of how you could use this in your everyday life. Anna's paycheck varies directly. Again, it tells us directly, so I know right now I'm going to use y equals kx as the number of hours she's worked. If we think about the independent and dependent variable, will the paycheck depend on the hours worked or the hours worked depend on the paycheck? Well, obviously, the paycheck would depend on the hours worked. So the hours worked would be my x value and the paycheck would be my y value. One way to know that right away is if I have a problem, what comes in front of the word directly is going to be your y value. What comes after the word directly would be my x value. So Anna works 15 hours and is paid $236.25. So we need to find our k value. We'd have 236.25 would equal k times 15. Now I can divide both sides by 15. So my k value would equal 15.75. Now I can write my equation of direct variation. So y would equal 15.75x. Now we want to find the pay for 40 hours worked. Well, remember that the hours worked was our x value and y was our pay. So y equals 15.75 times 40, which would equal $630. Makes sense. The more hours worked, the more she got paid. Okay? D. Your distance from lightning varies directly with the time it takes you to hear thunder. If you hear thunder 10 seconds after you see lightning, you are about 2 miles from the lightning. So again, directly is right here. So our distance is our y value, and the time would be our x value. If you hear thunder 10 seconds after you see lightning, you're about 2 miles away. So distance would be 2 miles, so I'll put that in for y. I'll have my k value, and I multiply that by 10, which is my x value, or the amount of time. I'm going to go ahead and divide by 10, divide by 10. So k would equal 1 over 5. My equation would be y equals 1 over 5x. Some of you might have gotten 0.2 there. That is fine as well. Okay. How far are you from the lightning? Again, distance was our y value. If you hear thunder 17 seconds after the lightning. So I need to find my y value by taking 1 over 5 times the 17. So my distance will be 3.4 miles. All right, now that we're done with that problem, let's go ahead and move to the back. There's a second type of variation known as indirect variation. Indirect variation is an equation in the form of y equals k over x, where k is a constant. It expresses the indirect variation. We say that y varies indirectly as x. Just like with direct variation, there are many applications of indirect variation. The more people that help pay defense, the less time it takes to complete. The fewer people who help pay for pizza, the more it will cost each person. And there are going to be many others. All right. So we need to find an equation of variation where y varies indirectly as x, and the following are true. So again, just like our direct variation problems, we're going to use the equation. This time, though, it says indirectly. That's the key word. So I'll put 15 in for y. I'll have my k over 5, multiply by 5, multiply by 5. I'm just solving for k there. So my k value would be 75, meaning my equation would be y equals 75 over x. Okay. On to b. I'm going to take 45 is equal to, again, it's still indirect, so k over 20, multiply by 20, just solving for k. So k would equal 900. Oops, didn't put the equal sign in there, did I? K would equal 900. So my equation would be y equals 900 over x. The biggest thing you need to realize is, what is it asking you for, direct variation or indirect variation? It will tell you straight out whether it is direct or indirect. Again, just like this, it says indirect. So we know we're going to use y equals k over x. It tells us the first set so that we can solve for our k value. So 6 equals k over 1.5. Multiply by 1.5 on both sides. So k would equal 9. Now we need to find y when x equals 3. So y would equal 9 over 3. Y would just equal 3. Notice that all I did here is I took my 3, plugged it in for the x value after I'd found my k value. Okay? Took my 9, which was my k, plugged it in for k. Took my 3, which was my x, and plugged it in for x. On to b. Same thing. We're going to do 3 is equal to k over 12. Multiply by 12 on both sides. That would get me 36 is equal to k. So now it says find x when y equals 6. So I'm going to plug 6 in for my y value. I'm going to plug 36 in for my k, and x just stays x. Now, this is going to have to be a two-step process to solve for x. I need to multiply by x to get the x out of the denominator. So I'll have 6x is equal to 36. Then I would divide by 6. So x would equal 6. I cannot just right now multiply by 36, divide by 36, or anything along those lines. I need to get that x out of the denominator, and we have talked about something like that in the past, so really that is just review. Okay? It takes 16 hours for 2 people to resurface gym floor. How long would it take 6 people to do it? This is an indirect variation problem. The reason why it's indirect is because the more number of people that I have to do a project, the less amount of time it should take. So this is going to be an indirect. We're going to use y equals k over x. Okay? So it says it takes 16 hours for 2 people to resurface a gym floor. Is the hours dependent on the number of people, or the number of people dependent on the hours? Well, the hours are dependent on the number of people, so that's my y. The people are my x. So I'd have 16 is equal to k over 2. Multiply by 2 to solve for k. K would equal 32. How long would it take 6 people? So instead of having 2 for x, I'm going to have 6 for x. So it would be y is equal to 32 over 6. I take 32 and 32 over 6. Remember, I don't really like decimals. You could get a decimal here. But 32 over 6 can be simplified into 16 over 3 hours. Don't really know what that means. So I could do y equals 5.33 hours or 5 1/3 hours. I would take either one of those answers. All right? 4 people have to pay $4.35 each for a pizza. So 4 people are going in on a pizza. How much would it cost each person if 5 people paid? Well, if you have 5 people instead of 4 people paying for the pizza, the cost of the pizza per person is going to go down as the number of people went up. So again, this is indirect. So y equals k over x. The cost of the pizza is going to be dependent on the number of people. So my cost is my y, the number of people is my x. So it would be 4.35 is equal to k over 4. Multiply by 4 to solve for my k value. That's going to get me k equals 17.4. Now that I'm using decimals and everything, obviously we're going to keep just using decimals. How much would it cost if 5 people paid? Well, again, my y value is the cost, so it would be y equals k, which would be 17.4, over my x value, which in this case would be 5. So if I take 17.4, divide them by 5, my cost per person would be $3.48 per person. And that is the end of our lesson. What you need to remember, the most important things about this lesson, is the fact that I'm using 2 separate just equations, and I'm plugging information into the equation to solve for something. Okay? So what you need to know is whether it is direct variation, which means that as one variable goes up, the other variable will also go up, or is it indirect variation, which means as one variable goes up, the other variable would go down. Once you have that little process figured out, the actual steps to figure out the equations and whatnot really are not overly difficult. Just be careful if you have a problem like B there on the back. 2b, I'm sorry, problem like 2b there on the back, that if you have k over a variable, you have to get the variable out of the denominator first. All right. Thank you very much for watching the video. Remember, if you have any questions, you need to bring them to me tomorrow, and have a great day.